Hello Algebra 2. This is the video for section 2 of chapter 3, which is all about graphing systems of linear inequalities. So not just lines now, but linear inequalities. We've graphed singles of these back in chapter 2. We could graph one of these lines and then we would shade it. Well, now the deal is we need to graph equation number 1, well, inequality number 1, shade it. Graph inequality number 2, shade it, and wherever they are both shaded, that's key. So here's the color scheme I'll be using in this video. Let's take this one for example. This dashed line here, again don't forget dashed versus solid lines in these linear inequalities coming from the symbols that they have there. So this guy is a less than or equal to situation. So that is this line here. Let me do that with a marker. That line there is the line, if you just use an equal sign. But then when it's less than or equal to that line, we're going to get all of these answers. And remember, me shading is the same as saying this point works, and this point works, and this point works, and this point works. All of these individual points are solutions to this linear inequality. And then I could do the same thing with this dashed line here, which is this guy, but I am greater than, so I want to shade above, greater than. Again, that's me saying this is a solution and this is a solution, and all of these points all along the way. Well, now that we have a system, two of these guys, the deal is I want to know, where do these solutions overlap? Where do I have blue solutions and orange solutions? And in this case, the answer is right here in what they've labeled as region 1. So we just need to graph two of these and figure out where do they overlap. Where both answers are located, that is your answer. So you could do something like point to it for me, or just make sure you like shade it really dark so I know it's this area up here. Do what you need to do. If you have colors, it's easy for me to see the overlap. If you just have a single colored pencil, just make sure it's a little bit darker so I know what's going on. So let's do 3 examples in this video today. Let's start with this guy because it is already in nice y equals mx plus b form for us to graph these. First one I see is going to be a solid line. I'm going to go down to my y-intercept of -3. My slope is 1/2, so up 1 over 2, up 1 over 2, or down 1 to the left 2. This is a solid line, and I will be shading greater than, so I'm going to shade above. And I'm going to go kind of light on this one, lighter than I did above, just so I can graph over top of this for the orange line. So, orange line now. This guy is going to be a dashed line. My y-intercept is 0. My slope is 2 over 1, so that's up 2 to the right 1, or down 2 to the left 1. I see they cross right there. This guy is a dashed line. Less than, so I'm going to shade below that line. And when I shade below that line, I see the overlap happening. So my solution region is right here. Solution region. And remember, if my line was solid, like this blue part of this little wedge region here, points on this line are solutions because it is a solid line. But over here, my dashed boundary, those are not solutions to the system. They don't work in both of them. So we're just keeping that in mind. So there we go. Let's go for this guy. I need to do some finagling before I graph this. So I'm just going to do a little bit of that. First one, I'm going to subtract over the x. If I subtract over the x, I get negative y is less than or equal to negative x plus 2. And remember, watch those signs there. This x is positive. When I subtract it over, it becomes a negative. This 2 is positive. It stays a positive. Because this subtraction sign was with the y, it has to stay there. Now, I need to divide by -1 to get this negative away. But when I do that, don't forget, we need to flip the inequality symbol. So this is now a greater than or equal to situation, positive x minus 2. So I start down at 2. My slope is 1, so up 1 to the right 1, over and over. This is a solid line. Because my new final inequality that I graphed is greater than, I'm going to shade above this line. Above the line. Next one, I need to subtract over the x. I get 2y greater than or equal to negative x plus 1. I divide by 2, so I have y is greater than or equal to. Sign didn't change because I didn't divide by a negative. Greater than or equal to negative 1/2 x plus 1/2. Running into the other one there. So I'm going to start up at 1/2, so halfway between there. My slope is negative 1 over 2. So down 1 over 2. Notice I'm still at the halfway mark, like within each box. Down 1 over 2, or up 1 to the left 2. This also is a solid line. That one is a greater than as well, so I'm going to be shading above. And I see the overlapping region right there. So this right here is my solution region. There we go. So wherever both of the answers are at the same time. Good. Last example. I'm going to scratch out this guy here, number 3, and let's graph this system instead. First one, and I put these in nice form on purpose because that's not the point of this example. Here we go. Let's graph these right away. I start up at my y-intercept of 1. My slope is 2. Dashed line. Greater than, so I'm going to be shading above the line. Above the line. All of the answers. There we go. The next one, notice something real quick. They have the same slope, but a different y-intercept. So right away we should be saying, oh, they have the same slope, but a different y-intercept. So we're thinking that these guys are parallel. And now we know that when we have parallel lines in a regular system of equations, I don't have an answer. I have an inconsistent system when my lines are parallel. That isn't necessarily the case in a inequality system. So if I graphed this guy, orange line, I start down at negative 2. My slope is still 2. Still a dashed line. Doesn't really matter in this case if they're when they're parallel, if they're both dashed or one's solid, one's dashed, whatever. Now this one I want to be less than, so I'm going to shade this way. Like I said, in a system of inequalities, we don't necessarily have no solution if they're parallel. If it's just a system of equations, guaranteed, parallel means we have no answers. But in this one, notice, again, I have no answers because this guy's answers are up here. This guy's answers are down here. So where are both of the answers? They're not. So this one has no solutions because there's no place where blue and orange overlap. It doesn't exist. Now, sometimes they do overlap. Like, let's say, I'm just going to use this one real quick, ignore this guy here. Let's just say I had a line that did that and a line that did that, and those are my inequalities. And let's say this guy I was greater than, and this guy I was also greater than. Where do both of them overlap? Over here. So, and notice something interesting about that one. Even though this guy, this inequality, would have all of these answers as well, where it's just orange, this guy has answers where it's blue, but the orange overlaps there. So really, the solution to this system is just the answers from this inequality. That can happen. It could also go like downward. The other option, again, ignore this guy for a second. Let's say I have, again, two parallel inequalities here. Let's say this guy's answers are less than So like this guy. And this guy's answers are greater than. Where are both of the answers? Right in here. So it's like a strip down the middle. So those are your options with parallel systems. We could either have no solutions because they're shading different directions. We could be shading both, either greater than or both less than, and we're going to get something that looks like this. Or if one's greater than, one's less than, and they go in the correct direction that they overlap, we do have a solution like landing strip there. So, hooray. That's all about graphing linear inequalities. Again, your answer is a picture, just like when we were graphing single linear inequalities. Now that they're systems, same thing. Your answer is a picture to me. So have at it. Again, I would say label the solution region for me so it's super duper clear, or if you're just shading it, just make sure it's really obviously darker wherever the answer is. There we go. So we will continue talking about systems of linear inequalities in class.